quantum tunneling. Quantum tunneling is one of the strangest phenomena in the world of quantum mechanics. It's a concept that defies our everyday understanding of how things should behave, especially when it comes to physical barriers. In simple terms, quantum tunneling allows particles to tunnel through barriers that they shouldn't be able to cross according to classical physics. Imagine rolling a ball up a hill. In the everyday world, if the ball doesn't have enough energy, it will roll back down the hill. The ball needs enough energy to reach the top of the hill before it can move to the other side. Classical physics tells us that if an object doesn't have the required energy to overcome a barrier, it will be stuck and unable to pass through. In the quantum world, however, things don't work the same way. Particles, such as electrons, do not always behave like solid, fixed objects. They act more like waves of probability, which means there is a chance for them to exist on both sides of a barrier, even if they don't have enough energy to pass over it. This is what we call quantum tunneling. Instead of being blocked by the barrier, there's a small probability that the particle will appear on the other side. The idea of particles tunneling through barriers is not something we observe in everyday life, but it plays a critical role in many quantum phenomena and technologies. One of the most famous examples of quantum tunneling is in nuclear fusion, which powers the sun. At the core of the sun, protons, the positively charged particles in an atom, fuse together to create helium. Normally, because protons have the same charge, they repel each other. But thanks to quantum tunneling, protons can overcome this repulsion and get close enough to fuse, releasing an enormous amount of energy. Another application of quantum tunneling is in modern electronics, particularly in devices like tunnel diodes and transistors. These components rely on the ability of electrons to tunnel through barriers in tiny circuits, making our modern technology, including computers and smartphones, possible. To understand quantum tunneling, it helps to know a little about the principles of quantum mechanics. In classical physics, particles are treated as solid objects that move in predictable ways. In quantum mechanics,